Navigational parameters. Navigating the vast expanse of the world's oceans requires precise knowledge of a vessel's location and direction. In maritime operations, navigational parameters are essential tools for charting safe routes, navigating cautiously, responding to changing sea conditions, avoiding hazards, and ensuring safe and efficient travel between ports. These parameters form the backbone of modern shipping, allowing vessels to plan, adjust, track, and optimize movement effectively using GPS technology. This is ABHA, and you're listening to part 5 of lessons on procedures and formats in SMCP. Navigational parameters. Core navigational parameters are heading, position, bearing, course and course over ground, distance, speed, time, geographical location. Heading. Heading refers to the direction in which a vessel's bow or front of ship is pointed at any given moment, measured in degrees from true north. It is crucial for steering and navigation, but it's distinct from the ship's actual path over the ground, which is called course over ground, COG. Heading is important for navigation, where it helps the crew to maintain the correct route in open waters. Collision avoidance, by knowing the heading and comparing with other vessels' headings to avoid accidents. Weather and currents, where ships often need to adjust their heading to compensate for wind or current drift, a process called crabbing or yaw correction. Heading is measured using a gyro compass or magnetic compass and is constantly monitored and adjusted by the ship's autopilot or helmsman. A ship's heading is displayed on radar and ECDIS, Electronic Chart Display and Information System. On a radar screen, the ship's heading is shown using a heading marker, which is a straight line extending from the center of the ship to the edge of the screen. This line points in the direction the bow is facing. Heading line helps ensure everything is properly aligned. ECDIS integrates data from gyro compass and overlays it on digital nautical charts. This helps seafarers visualize the ship's orientation relative to charted features, compare heading with course over ground, and track. Position. Position refers to the exact geographical location of a vessel at a specific time, expressed in latitude and longitude coordinates. It is determined by using navigation tools such as GPS, radar, or traditional chart plotting. Ships equipped with Automatic Identification System (AIS) transmit their position automatically, providing precise coordinates to other vessels or coastal stations. Knowing a ship's exact position helps prevent collisions, assists crew in following planned routes, and allows authorities to track vessels for security and safety. A ship's position at sea is determined in terms of latitude and longitude, degrees and minutes, north or south of the equator, east or west of Greenwich. Latitude and longitude are calculated at the point where a meridian and a parallel intersect. Latitude is the distance north or south of the equator measured from 0 degrees to 90 degrees. Longitude is the distance east or west of the prime meridian measured from 0 degrees to 180 degrees. Meridians are imaginary half circles running from the North Pole to the South Pole. Parallels are imaginary lines running parallel to the equator. Examples of position reports. Warning: dangerous wreck in position 15 degrees 34 minutes north, 061 degrees 29 minutes west. Latitude and longitude. Example: 12 degrees 34 minutes north, 45 degrees 67 minutes east. Bearing and distance from a fixed location. Example: 100 nautical miles southeast of Ho Chi Minh City. Proximity to a geographical location. Example: 10 miles west of Haiphong. Heading and speed. Example, heading north at 15 knots. Bearing. Bearing refers to a direction or position expressed in degrees and measured clockwise from a reference point. It is a crucial element of ship navigation, helping seafarers determine the direction from one point to another. Ships calculate bearing using manual techniques and global positioning system (GPS). Importance of bearing in navigation. Bearing assists ships in navigating safely and maintaining the planned route, locating vessels in distress for rescue operations, reducing fuel consumption by following the shortest and most efficient paths, adjusting routes during adverse weather conditions for smoother passage, avoiding hazards such as shallow waters, rocks, and restricted zones. Types of bearing. Bearing is measured relative to different reference points. True north. Bearing based on the Earth's geographic North Pole measured clockwise from 000 degrees. Example, the ship needs to maintain a course of 045 degrees true to reach its destination. This means the bearing is 45 degrees clockwise from true north. Magnetic north. Bearing based on the direction a magnetic compass aligns with the Earth's magnetic field. Example, steer 030 degrees magnetic to follow the designated route. This means the bearing is 30 degrees clockwise from magnetic north. Relative bearing. Ship's bow as reference. Bearing measured clockwise from the bow of the ship with 00 degrees at the bow and 180 degrees at the stern. Examples. The lighthouse is at a relative bearing of 090 degrees. This means the lighthouse is directly on the starboard side of the ship. The lighthouse is at a relative bearing of 180 degrees. This means the lighthouse is directly behind the ship. Practical uses of bearing. Bearing helps determine the direction relative to fixed points such as another ship, a lighthouse, or a waypoint. Bearing is essential for maintaining orientation at sea, planning maneuvers such as avoiding obstacles or when approaching a harbor, ensuring precise navigation, course plotting, and vessel positioning in maritime operations. Course and course over ground (COG). In navigation, the course of a ship refers to the cardinal direction in which it is steered, essentially the planned route a vessel follows to reach its direction. However, the course over ground (COG) represents the actual direction a ship moves on water, influenced by external factors such as currents, winds, and tides. A ship's course is measured in degrees, while COG is verified through real-time tracking systems. Both are essential for ensuring precision in maritime navigation. Key differences between course and COG. Course is the intended direction plotted during voyage planning. COG is the real-world movement of the ship, which may differ due to environmental forces such as winds and currents. How ships navigate using course and COG. The helmsman steers the ship using the planned course, adjusting the wheel or rudder to maintain the intended heading or planned route of the ship. Navigators monitor COG continuously via GPS to ensure the vessel follows the planned trajectory. If the COG deviates, corrective actions such as adjusting the heading or engine power are taken to minimize drift and stay on track. Importance of course and COG in navigation. These ensure efficient and safe passage between ports, help seafarers compensate for environmental factors like strong winds and currents, allow ships to follow optimized routes to reduce fuel consumption, prevent unintentional drift that could lead to delays or hazards. Distance. Distance in maritime navigation is a critical measurement used to determine how far a vessel has traveled or needs to travel. Distance measurement, whether nautical miles or kilometers, is fundamental for charting courses, estimating travel times, and managing fuel efficiency. By integrating UTC, time zones, and advanced navigation tools, seafarers can ensure smooth coordination in global shipping operations. Units of measurement. Distance is measured in nautical miles (nm) or cables. Nautical miles (nm) is equal to 1,852 meters based on the Earth's circumference and corresponding to 1 minute of latitude on the globe. Cable is 1/10 of a nautical mile, about 100 fathoms. Importance of distance in shipping. Distance represents the length of a planned route between 2 points, whether across oceans, through canals, or along coastal waters. Accurate distance tracking helps optimize fuel consumption, voyage time, shipping costs. Methods for measuring distance. Seafarers use different navigational techniques depending on the route. Great Circle Route. This is the shortest path between 2 points on the Earth's curved surface. Often used for long-distance oceanic navigation to reduce travel time and fuel usage. Rhumb Line. This route maintains a constant bearing, crossing all meridians at the same angle. It is easier to follow, but not necessarily the shortest route. Factors affecting distance in navigation. Ship navigators account for external conditions such as winds, currents, and tides, which impact the actual distance traveled. Use of precise navigational tools like GPS and radar to determine the safest and most efficient routes. Timekeeping and distance. Accurate distance calculations depend on precise timekeeping. Universal Coordinated Time (UTC) ensures global synchronization, preventing discrepancies in position reporting and communication. Time zones are crucial in voyage planning, ensuring smooth scheduling and compliance with international maritime regulations. Speed. Speed in maritime navigation is expressed in knots, a measurement that simplifies calculations involving latitude and longitude on navigational charts. Understanding speed in knots helps navigators efficiently plan voyages, maintain course accuracy, and adjust for environmental conditions. By carefully regulating speed, ships ensure operational efficiency and safety while navigating global waters. Units of speed in shipping. Knots (KT) is speed measured in nautical miles per hour. Nautical miles (nm) is approximately 1,852 kilometers based on the Earth's circumference and corresponding to 1 minute of latitude. Calculating speed. Speed is determined using the formula speed is equal to distance divided by time. Examples. A ship travels 14 nautical miles in 1.5 hours, hence the speed equals 9.3 knots. A vessel that is traveling as 20 knots is moving as 20 nautical miles per hour. Importance of speed in maritime operations. Regulating speed is crucial for optimizing fuel consumption, ensuring timely arrival, maintaining safe operating limits. Time. Universal Time Coordinated (UTC) is the global time standard used in the shipping industry to synchronize maritime operations across different time zones. UTC and Zulu time notation. 24-hour UTC format ensures uniformity in scheduling worldwide. Also known as Zulu time Z, where a Z is added directly after the time without a space. Examples. 09.30 UTC can read as 09.30Z or 0930Z. 14.45.15 UTC can read as 14.45.15Z or 144515Z. Importance of UTC in maritime operations. UTC is essential for coordinating voyages and schedules across different time zones, maintaining consistency as UTC does not adjust for daylight saving time, preventing discrepancies in arrival and departure times. Local time adjustments in shipping. Captains can adjust the ship's clock as the vessel enters new time zones. Local time at ports is used for scheduling arrivals, departures, and cargo operations. Common time references for shipping. Maritime schedules often use ETA, estimated time of arrival, which is the expected arrival time at a port or location. ETD, estimated time of departure, which is the planned departure time from a port or location. ETC, estimated time of completion, which is the estimated time for completing tasks such as loading or unloading cargo. Precise timekeeping plays a crucial role in navigation, influencing arrival predictions, fuel efficiency, and operational schedules. Maritime professionals rely on UTC, ETA, ETD, and ETC to ensure the efficient and timely movement of vessels across international waters. Geographical locations. Geographical locations used in maritime navigation appear on ship charts and help identify locations during a journey. Using latitude and longitude to locate places. Latitude and longitude are essential for pinpointing locations on a map. Example: the latitude and longitude of Ho Chi Minh City in Vietnam are approximately 10 degrees 46 minutes 32 seconds north, 106 degrees 42 minutes 07 seconds east. Standard way of reading geographic coordinates. Latitude 10 degrees 46 minutes and 32 seconds north. Longitude 106 degrees 42 minutes and 7 seconds east. Importance of geographical names in maritime navigation. Geographical names such as ports, landmarks, and coastal areas assist seafarers in navigating safely using precise coordinates, communicating location information effectively, planning voyages with accurate reference points. How navigational parameters relate to one another. Navigational parameters work together to enhance voyage planning, route optimization, and hazard avoidance. Each parameter complements the other, helping seafarers optimize routes, avoid hazards, maintain a smooth voyage, and make real-time decisions with accuracy. Key navigational relationships in maritime shipping. Position and bearing. A ship's position indicates its exact location at sea, which determines the bearing or direction to a location such as a port, buoy, or waypoint. Accurate bearing supports efficient routing and reduces the risk of navigational errors. Distance, time, bearing, and course. Distance to a location is calculated using bearing, which helps establish the correct course, and the distance covered affects the estimated time of arrival, ETA, making time a critical factor in voyage planning. Course and speed. The course defines the intended path, while speed determines how quickly a ship moves on that path. This directly affects fuel consumption, delivery punctuality, and voyage cost forecasting. Position and distance. A ship's position determines its distance from a destination, which is essential for real-time tracking, planning, bunkering, or cargo readiness. Speed, time, and distance. Speed influences the time required to cover a specific distance, while speed adjustments can optimize fuel efficiency or accelerate delivery under time-sensitive contracts. Geographical locations and position. Geographical locations such as ports, islands, and markers serve as reference points to help ships pinpoint their precise position. Accurate positioning supports coastal navigation and port approach maneuvers, and ensures compliance with local maritime traffic rules.
Hi everyone, it's my pleasure to be here. My name is Phong, Papa Hostel Oscar November Golf, and I'm a 4-year student at University of Transport in Ho Chi Minh City. And my major is Maritime Navigation. Lucky me that I passed a scholarship of Royal Wagon Board Shipping Companies, and I have opportunities to learn English with a foreigner. She is a beautiful Indian. Her name is ABHA, and it's been 3 years since we first met, and my English is much better now. And she taught us not only the communication English, but maritime English. And for communication, we often discuss about what we meet in a day, what a funny situation, and that will help you be more confident when you're telling something. And for maritime English, she often gives us about maritime lessons, and she also shows us how to have a good body language, speak clearly, and is that good for us when we have an interview with our companies. And for now, she's opening online class. It's a good chance for you guys if you want to improve your English, have a good job in the future. Resist now. Thank you.